Hello again. And I just wanted to make sure that we just got a head start on this cardiac unit. And so I will, this is the PowerPoint to 17. Again, I'll send you a separate email where this is. We do mostly 17A. The 17B I will do in the lab because I like to do the electrocardiogram. I'll do that next time. A is more of the anatomy, minimal amount of physiology that's included with it. So the physiology I like to do with the cardiac unit is the conducting system. So that's what we'll work with. So let's get that situated and started. And here it is. Think of it, it's a side by side pump. Two identical pumping units, one going to the lungs to reoxygenate blood, one basically taking that now oxygenated blood and distributing it to the rest of the body. So we're divided into these two side by side pumps. And interestingly, the pumps have effectively two chambers each. So it's a total of four. The upper chambers are minimally involved other than at the just before the actual pumping starts. They're called atria. They're small, they expand when there's fluid, but by and large, blood comes in there transiently, and only the last amount of blood that accumulates in there is actively pushed into the lower chambers, the ventricles, to be eventually pumped or distributed to either the lungs or the rest of the body, depending on which side you're on. The right side, called the pulmonary circuit, beg your pardon, blood enters by way of the through a variety of openings into the right atria. It's carried almost immediately, almost just it's almost like there's an opening. It flows into one and immediately flows and starts to fill the ventricle. When the ventricle is filled, and we start what's called the heart cycle, which is something that's more you do in the lecture in physiology. It pumps the blood to the lungs, transits its way comparatively slowly through the lungs, and makes its way back to the other side of the heart. What happens in the lungs? It replenishes the oxygen supply, which is about 75% to start of what it should be, and then it comes back to 100%. That's the pulmonary circuit. The way back, once it's back to the left side, same thing occurs. Comes through the left atrium, fills the left ventricle almost immediately thereafter, and then just a little bit is topped off as the atria start this, what we call the cycle, and then the ventricles fill, power up, so to speak, and the blood is pushed out with a great deal of force and relatively rapidly into or towards the rest of the body. That's called the systemic circuit. So that's really the two circuits, and you'll see them here depicted. So the right atrium is receiving for systemic circuit, meaning it's the blood coming back for systemic, and the left atrium coming back from the pulmonary. And the outflow points are the right ventricle of the pulmonary circuit to the lungs, and the left ventricle by way of the aorta throughout the rest of the body. And this is the common diagram. Uh, these are closed circuits. There's not like a little opening here that comes into it or a little opening that here comes into it. The blood leaves the heart by way of the aorta, goes through all the body, is immediately received back into the starter veins, which are carried back to the heart, and then it's all closed, goes to the lungs, same way. So it's not as though it's leaking out in places other than by intent. So that's what I mean by it's effectively a closed. It's like think of it as a continuous tube where the heart's in the middle of it, and you have pumping stations sort of in the middle of it. So one station starts here, sends it all the way around, and that really going backwards that for you. Oops. So I mean, here you basically look at this. You look at it. What's going on here is coming in from the rest of the body, going through the chambers, being pushed to the lungs, and then finally coming back. And you can see the color change. So it goes from being blue, think of it as venous or deoxygenated blood, to red, arterial blood. It's smaller than you think, less than a pound, roughly the size of your fist, depending on what it is. The mediastinum is that area between the two lungs. It's right underneath. The bulk of it is underneath the sternum, slightly to the left side as development has gone on. It's between, we feel the spaces. And this is where you put a stethoscope or where you'll typically put certain kinds of leads when you do an electrocardiogram. They're called intercostal spaces, spaces between the ribs. and it's roughly located between the second and fifth spaces. It sits on top of the diaphragm. Because of its development, though, it started in gestation, in utero, centrally with chambers equal on both sides. But what happened, it became more muscular on the left. So the bulk of it, volume and mass wise, has gone to the left. And it sits in front of the vertebral column and behind the sternum. That's just what they're saying here. And you see the location. So this is what we're looking for when they talk about here at the apex, the so-called apical pulse. That's where you really want to get that sound of the pulse distinct through a stethoscope. That's where you put it. So we use these anatomical markers. This is surface anatomy. You feel the intercostal spaces. You use the nipple line. You use the edge of the vertebral column. You use the central area. You don't want to obviously put a stethoscope right on top of the bone. Can't hear very well. So anatomical landmarks are very, very significant. Effectively, this is if you did a cross section, you can see the girth of these chambers. The atria are here, but they don't have a lot of muscularity. So the volume is deceiving. But here, because of all the muscularity, this is folded again. So when it fills, it has a substantially larger amount of volume. Roughly the volume of each of these chambers is identical, though they may not look the same, again, because the muscularity kind of obstructs it, are about 4 ounces each, where the atria have, much less, maybe, an ounce of fluid is the most that's pumped in there that really stays in there. It doesn't stretch a whole lot, maybe a little bit. And so we talk about the base and the apex. The apex, as you saw before, that apical area was down, sort of downward and to the left. So it's pointing toward the left hip. The base is pointing up toward the right shoulder. That's sort of the angle. And then again, you look between the fifth and sixth ribs and use the nipple line on the left as your anatomical landmark to detect that pulse. So it's a pretty good view here. You'll notice the vessels don't exit. In the diagram, I'll create a drawing either on the board, maybe Friday, and take a nice picture and send it to you using the lab and just taking a quick picture of on the whiteboard, as I find it easier to do it that way, and demonstrate that to you. But effectively, the vessels, I don't draw it this way. I draw it almost like a box diagram. And the vessels, you can see exit the top. What's happened as the heart has developed and become more and more muscular, it's almost like somebody who's doing curls with their forearms and their biceps and brachialis muscles. It's developing those muscles so much that if you can imagine holding your arms down and out straight, it's as though they've contracted over time with all that muscularity, and the exit points being your wrists and hands have come up. And I'll show you that a little bit when we get into lecture next time. So I'm not doing a long one for this right now. So this exiting here in blue would be called the pulmonary trunk, and it divides into the left and right pulmonary arteries. And you're going to see, so you'll see a lot of these different ones. Let me rephrase that for you. This is the pulmonary trunk. And here you can go to the left and then to the right, which is obscured here. You can see it's exiting here. It appears to be rather a large chamber, the right ventricle. You're seeing the anterior wall. The bulk of the mass that's on the anterior part of the heart is left ventricle, because it's much more muscular. So there's more mass this way, but a little more surface area on this. These sort of slightly odd colored and you can see that sort of interesting pattern that they have, are called auricles, because they reminded anatomists of little ears. And we call them the auricular chamber. And what they are is expandable chambers that sit on top of the very small atria. And when you do the heart dissection, you'll see that as well. This, by mistake before, is the superior vena cava. It drains, and that's the word we use when we have blood coming in veins. It drains the head through the carotid portion. These are called the jugular veins, the part going to the head that mate to the carotid arteries. And these are called the subclavian. And they go under the clavicle and out to the upper extremity. So the drainage, or the venous return from the upper extremities, left and right, confluence together. And we'll go over this when we do the anatomy. They're called brachiocephalic, just means head. It just means like arm and head veins come together and they marry to form the superior vena cava. Not pictured here as an incoming vessel that's the widest in your body because veins are wider than arteries, is called the inferior vena cava. So that's two of the things that enter here. And under this auricle is the atrium, the right atrium. And there's also a little opening in the back called the coronary sinus. Coronary because it has to deal with the coronary arteries, but it's really where all the veins, which interestingly are called cardiac veins, come together in the back or posterior aspect of the heart and enter the aforementioned right atrium. So there's three entry points on that side. So this, and really it's sort of exiting at an angle, it's kind of shooting up from here from the left ventricle. It's a very famous aorta. It exits here. You can't see it pictured here, but you will subsequently. Is where the coronary arteries, right after the start of this, they immediately feed the heart. The heart feeds itself first. And this is called the aortic arch. We'll go over the three vessels that come from it. Then it goes behind the heart. That's called the descending or thoracic aorta. And when it goes through this structure, the diaphragm now becomes the very famous abdominal aorta. So you'll see that. The heart is surrounded by a very thick tissue that we probably don't have on our hearts because it costs more when you buy them. And all they are just layers of connective tissue called the pericardium, which means around the heart. So it's a double-walled sac. And what's interesting, the very thick hard part is called the fibrous pericardium, and it really anchors it. And then underneath it is what's called the serous pericardium. That's a more delicate lining, and you probably covered this in the first part of Anatomy and Physiology 1. What surrounds the heart is this double layer of actual serous. Serous means it secretes a little bit of a fluid, like a lubricating fluid. And it's got a layer on the wall called the parietal layer, and then it's got a layer on the heart itself, which is called the visceral layer. And that's where we call the pericardial cavity. I'm going to stop and pick this up because I have a phone call coming in, so excuse me. Wait a second. Hello.